Action.
Okay, the first thing we'll do is verify the zero on our tool, on our depth mic. I'll bring it down to the surface plate. And we verify that we have a good, accurate zero reading when I'm zeroed on the surface plate. And that's going to be the basis for our readings. Our measurements will be from the surface plate to the top of the surface of the part. The first thing we'll verify is the B dimension, which is a solid measurement from the top surface to the surface plate. Then we will measure the difference from the B surface to the C surface, subtract that difference to get the net C dimension, and we'll use a similar method measuring the depth from the B surface to the A surface to get the net thickness of the A dimension. So now we'll come over and measure the B thickness on the actual part with a minimal amount of pressure holding the part down to the surface plate. We extend the depth gauge to make contact with the surface plate, and we have a dimension there of 0.159, slightly over 0.159. So I'll make a record of that B dimension being 0.159, and we'll call that 5, roughly half a thousandth over 159, which is within our tolerance of 0.157 plus or minus 3. It's slightly plus from nominal, but it's still within the tolerance. Now we'll measure the difference from the B surface to the C surface. Retract the depth gauge, rest on the B surface, measure to the C surface. That dimension is 0.0305. 0.0305. So we'll subtract that from our original dimension. 0.1595 minus 0.0305 equals 0.129. So that would be our C dimension. It's 0.129. Requirement is 128 plus or minus 3. So C is 0.1290. Now we use the same method to determine the difference from B to A. And that number is 0.9765. 0.097. Excuse me. Let me rethink that number. That number is 0.0965. Yes, thank you. So if I take my original dimension, 0.1595, subtract 0.0965, that leaves me with a thickness of 0.063, which is right within the tolerance of the A dimension of 0.062 plus or minus 3. So again, my A dimension is 0.063.